If you're a space nerd like I am, you probably remember the Kepler Space Telescope. The telescope was launched in early 2009, and it trailed after the Earth in its orbit around the Sun. It was operational for more than 9 years before it ran out of fuel for orbit adjustments and maintaining its orientation as it orbits the Sun, and so it was retired in late 2018. Now, during the course of its life, the Kepler telescope observed over 530,000 stars, and it's detected over 2,600 confirmed exoplanets. Well, today I have some cool news for you from the Kepler Data. Now, this was a mission that involved a tremendous amount of information. I mean, we're talking about literally many tens of thousands of individual stars, and it requires computer algorithms to automatically sort and organize the colossal amount of incoming data. On the website Reddit, NASA made a post about the discovery, and in the comment section, I was fortunate enough to be able to talk briefly with Mr. Jeff L. Coughlin, who is a co-author of the paper. I asked him about the scale of this data analysis, and he said that Kepler, quote, had just shy of 200,000 targets, each that had 4 years of observations of their brightness, taken every 30 minutes. That's roughly 1 billion data points in total. It took several years to analyze and publish the catalogs using automated analyses, resulting in over 4,000 planet candidates, unquote. He also explained that follow-up human oversight, which included the manual double-checking of all of these data points, it took several years, and recently, a planet that had just barely slipped through the algorithm was identified, and Mr. Coughlin said, quote, "There's undoubtedly more planets buried in the data waiting to be found by new techniques that might be more sensitive than what's been used in the past," unquote. In NASA's article in the post that they made, they quoted the lead author of the paper, Andrew Vanderberg, who is a researcher at the University of Texas at Austin. Mr. Vanderberg said, quote, "Out of all of the mislabeled planets that we've recovered, this one's particularly exciting, not just because it's in the habitable zone and Earth size, but because of how it might interact with this neighboring planet. If we hadn't looked over the algorithm's work by hand, we would have missed it," unquote. Alright, so this is pretty exciting, and he also mentions a neighboring planet, so we'll explore that in just a minute. For the moment, let's take a look at this Earth-sized planet itself. So this world has been labeled Kepler 1649c, and it orbits a red dwarf star that's about 300 light-years away from Earth. On a galactic scale, this is relatively close by. I mean, it's certainly not one of the nearest stars, but considering that our galaxy is more than 100,000 light-years across, 300 light-years is just down the street. This exoplanet, Kepler 1649c, orbits its red dwarf star every 19.5 days. This is Earth days, to be clear. What's also interesting is that there's a second rocky planet, that's this neighboring planet that Mr. Vanderberg mentioned. This second rocky planet orbits at about half the distance, so it orbits a lot closer to the star than Kepler 1649c. Now, as the star is a red dwarf, it's relatively dim and cool, and so planets can be Earth-like at a much closer range than they could be compared to our star, which is a subgiant yellow G-type star. But around one of these cooler, dimmer red dwarf stars, well, even this second planet is too close to be habitable. It orbits too closely to have anything resembling an Earth-like atmosphere. It's way too hot, and it's probably tidally locked. Now, to quote the NASA article about the discovery of Kepler 1649c, they say, quote, "This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from its host star is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. But unlike Earth, it orbits a red dwarf. Though none have been observed in this system, this type of star is known for stellar flare-ups that may make a planet's environment challenging for any potential life," unquote. Now, I've actually talked about this phenomenon before, in a few other news segments about exoplanets. and I talked about this in greater detail in my special series on the life in the solar system. If you'd like to know more, listen to the first episode in that playlist, Life in the Orbit of the Sun, and it goes into a lot of detail on red dwarf stars and other stars and what that means for life on planets in their orbit. But anyway, here, in this situation, it looks like the deadly radiation flare-ups, they might be a risk, but as none have actually been observed, it's quite possible that this particular star is simply a more stable variety of red dwarf. And the really cool thing about this is that red dwarf stars naturally live for a very long time. They're small and dim, they don't use their fuel quickly. So any life on this Earth-sized, potentially Earth-like exoplanet will have tens, hundreds, or maybe even thousands of billions of years to evolve. To quote a larger passage from NASA's press release from their article about this, they say, quote, Kepler 1649c not only is one of the best matches to Earth in terms of size and energy received from its star, but it provides an entirely new look at its home system. For every 9 times the outer planet in the system orbits the host star, the inner planet orbits almost exactly 4 times. The fact that their orbits match up in such a stable ratio indicates that the system itself is extremely stable and likely to survive for a long time. Nearly perfect period ratios are often caused by a phenomenon called orbital resonance, but a 9:4 ratio is relatively unique among planetary systems. Usually, resonances take the form of ratios such as 2:1 or 3:2. Though unconfirmed, the rarity of this ratio could hint to the presence of a middle planet, with which both inner and outer planets revolve in synchronicity, creating a pair of 3:2 resonances. The team looked for evidence of such a mystery third planet with no results. However, that could be because the planet is too small to see, or it's at an orbital tilt that makes it impossible to find using Kepler's transit method." Unquote. Alright, this is super awesome. So not only do we have a potential Earth analog in a particularly stable star system, we have the possibility of a third, smaller, rocky planet that sits somewhere on the warmer edge of the habitable zone, between the scorched innermost planet and this Earth-sized outer planet. The fact that there's 2 potentially habitable planets in a stable, long-lived star system holds fantastic potential for life. I think this star system should become a high-value target for future research involving higher resolution imaging, spectroscopic analysis, and a search for biosignatures. The NASA article goes on to describe the variables that remain unknown, specifically the planet's atmosphere. Depending on the density, the weather activity, and the chemical composition of the atmosphere, the planet could be remarkably Earth-like. Or it could be another inhospitable hell planet like Venus, with an atmosphere composed of 99% greenhouse gases. Mr. Vanderberg said, quote, "The more data we get, the more signs we see pointing to the notion that potentially habitable and Earth-sized exoplanets are common around these kinds of stars. With red dwarfs almost everywhere around our galaxy, and these small, potentially habitable and rocky planets around them, the chance one of them isn't too different than our Earth looks a bit brighter." Unquote.